Hi, my name is Merrick. I'm going to be talking about using React on your source code or in the context of your code, particularly in the context of a tool I built called React Sorcerer, which is effectively a linting framework built in React. So the definition of React is to respond or behave in a particular way in response to something else, right? Normally, this looks like React sitting in between your state and your interface and keeping your interface up to date and responding to your interface to keep your state up to date. React Sorcerer is kind of interesting because it takes your state and it says, what if your state was actually your source code? What kinds of interfaces could we build and how could we respond to those interfaces to then update our source code? Our example code that we're going to be going through today is this. We're importing underscore or Lodash. We have a list of fruits. We're going to iterate over each fruit and just alert the fruit name. Our goal is going to be able to detect that they're using Lodash, detect that they're using the for each method, make a recommendation to use the built-in for each method, reauthor the code for them, and then provide a helpful link to learn more about the built-in for each method. First thing we need to be able to do this is detect patterns in code. Namely, we want to figure out if they're importing Lodash. If you were to do this yourself, it would be a little difficult to just take the string into the component, especially because they can import it as something other than underscore. Regular expressions are fairly limited. And the first tool React Sorcerer offers is the AST provider. And the AST provider is very simple. It simply takes your source code and provides it in the context of a state tree. So we run it through Babylon, and then we have state much like your React state. And there's some interesting parallels if you think about your state tree in Redux versus your source code state tree. So you provide AST provider your source code, and now you can write detectors or matchers, as we call them in React Sorcerer, within the context of that source code. To implement the Lodash detector, we use the bread and butter of React Sorcerer, which is the match component. The match component matches patterns in code given a provided matcher function. So you provide a true or false return value with a node that we give you every node in the tree, and you provide a true or false return value. We gather them together, and then we provide them back to you so you can render them however you like. Whether that's storing them off in some history that you can then look at the history of changes, or in our case, producing this error. To write the Lodash detector, we would provide a callback that uses the Babel types package to ask, hey, is this an import declaration? If it is, are they importing from Lodash? In which case, we get the callback. The problem is you have to know about the state tree, right? Or the abstract syntax tree. You can also get on match callbacks if you need to do lateral composition or if you need to store the results of a matcher inside of your state. React Sorcerer comes with a lot of pre-built matchers, and this is really what's compelling about it. Is your matchers can actually start to look like more generic or abstract forms of your code. So to import from Lodash, we actually write a React component that looks strangely like the code. So this will match files that import Lodash or import from the package Lodash, in which case we take whether or not they imported Lodash, and we can render whether they're using Lodash or not. Scope matches is something that React Sorcerer does to solve a very specific problem. Say they're importing it as underscore, which is kind of the default, but they sometimes might call it Lodash. A developer might use named imports. They might do some combination of the two. And this is why working with strings is very difficult. So what we could do with scope matches, we could take the results of one matcher, so take the output of the imports matcher, and use that as the context for the identifier matcher within it. So now we're only walking on the results that positively pass the imports matcher, in which case this will print all of the identifiers or local variables imported from Lodash. Nested matches are interesting because we'll render the child every time. However, you don't have to limit the search to just that child, but you can use the results of a matcher. In this case, I'm grabbing all the identifiers from Lodash, and I'm configuring the member expression matcher to say anything imported from Lodash. If they imported Lodash as jQuery, and then they called for each on that, I will know that they called Lodash.forEach, even though they called it jQuery or whatever they may have called it, because I'm using their code to inform my additional matchers, which we can then render our helpful message around ES 2015 each, because the matches will include the line numbers, et cetera. If you're interested in this experiment and kind of where I'm going with this, this is the link to the repository Thank you so much to the organizers and each of you for listening and for the opportunity to share this stage. It's an honor. Thank you.